Hello and welcome to this video. It will be a bit technical. This is a post-mortem about something I did this weekend. I did a hackathon, and in this hackathon I had to record a lot of image in a high frame rate to be able to generate image to send to an AI. So if you have interest in the AI part or the recording part, it could be interesting you, so feel free to follow this video. Let's see what I did and let's have fun. So here is a mesh here, and it is the dancer that is dancing in the hackathon. So as you can see here, up, I will split that. So we have a guy here who will dance, okay? And to this guy, we put the camera on the torso. So if you look here, you can see that here is the dance, but here it's a bit weird. Why it's weird is because, here we have the camera, and the camera is sending the rendering in the mesh renderer. That is, do you see it here? So if I click on the mesh renderer here, I just choose an image dimension that I want to record, and the format, etc. So you can see that the image is loading over there. And what happened here is that I can do two stuff. First stuff is to record everything, and the second stuff is to take pause recording. So I show you here, I press 0. Okay, I wait a bit. I press 0. I wait another position. Press 0. Okay, so every time I see a position I like, I press 0. Now what I do is I press 1. What happened is I kill the animator, then take the position to the position it was, and move a bit the pivot, the anchor. So if I want this, I will do like this. I have plenty of image of one position to give to the AI. So you can see that here. Push to 2. Screenshot, number of screenshots here, frame body position recorder. So yeah, the Git is online, so you can go online to fetch it. I will maybe put myself here because there's a lot of information on the side. Like this, okay. So as you can see here, frame body position, what I do is that every time I press on 0, I will do an array of what I need to record, and when I press 1, I will record them. And what happened is that I just saying here, screenshot, can you take a screenshot? Okay. And here screenshot is frame screenshot here. You will see that the frame screenshot will send it to a thread, if I remember well. And the thread will record those. The idea is that if you take the image and try to store it as a JPEG or a PNG, you will lose a lot of time on the frame rate, and the encoding part of Unity is only on the main thread. So you will lose a lot of time encoding the image. So what I do instead of encoding the image is to, no, it's not this script, is to send it to someone who can record, who can store it. So frame position, take a screenshot, TMP push renderer, here, this. So I say, can you save it and push it on the thread? Okay, so he will send it over there. So what I do is I take the texture, texture 2D, I said rendering texture, I need to copy something, so I give the source that is over there. Okay, and this is the camera I want to record. I say, could you copy all that in there in the texture, and then I say, okay, push this color, this texture. So if I go to see the other one, here you have the ability to say, I want to save the color or I want to save the texture. If you say I want to save the texture, the only stuff I do is to take the color and the dimension here. And when I have it, here. What happened is that in your case, you should just record the image. But in my case, I need to record the image and when it happened in the animator. So I have the animator over there and I say, okay, this color stuff and height and white, I need to know when it did happen. So I take the current animation, then to have the time, I multiply the current time by the duration of the current clip, the one I'm playing for now. So the one where it's we are running. And like that, I'm able to store the texture, but also the millisecond when it happened. Because now that I have the millisecond of when it happened, I can say later on, this texture is this millisecond, and so I can associate some action to this texture. I need to be able to say this exact frame, there is something that happened. And that's what we do here. So we recover the frame as a millisecond and send it over there. Okay, so we unqueue it in the stack here. Why I'm unqueuing it in a stack and why in a queue is because what will happen is that now we have the color that is in the memory RAM of your device. So it will take a lot of size, like 60 MO, something like that, when it's a high texture, a 2K texture. So now that we have this 60 MO in the memory, we need to keep it there the time to be able to do something about it or to write it in the file. Because if you don't, you will quickly have no memory at all. Because 60 by 60, you are in some seconds, you already are in the gigabyte of RAM used. So what you need to do is flush it the faster you can on the file. So I put that in a stack. And what happened here is that when I start the application, I create some thread that is here. So I say, okay, when I arrive in the scene, I want you to give me the persistence data path where I need to store it. Give me some save time. It's to be able to say we are using thread. So if the application die or something bad happen, I want to have a save time to kill the thread when the application is dead. Because else you could have plenty of thread running around. Because what we will do here at the wake, we'll say, okay, I need some thread, and you will create several threads like this that will look at the queue and extract them. So here, if I go here, up. What I do is that the thread will run all the time, but it will die if it makes too much time, it's not update, or if we ask him to die from outside, so from Unity. And so here what I do is that I say, okay, how many images must we store on the file? If it's under 50, yeah, take 1. If it's over 50, take 3. If over 60, take 10. So more we have waiting image to store, more we need to slow down the frame rate and go write it down quickly, because as soon as we arrive to a certain amount of memory RAM, it will crash. So if we have 200, we really need to flush them down in the file. And so sorry for the frame rate, but okay, we need to make them go away. So as soon as we have the number of frames we want to make go away, we need to make them go away. So we ask here the number of stack there is. If there is one, we increase the number to see how many images had been done. We take the information here. We log the queue because we need to dequeue the stuff in a multi-thread situation. Now that we have an item, what we do is that we convert to byte. So how I convert to byte here? Here. So you have this cool method that allows you to convert a certain type of information into byte and certain byte into color array. And so that's what I do here. I do the conversion like this. So where were we? We are, yeah, we were in the bottom of it. Okay, so here I say, okay, I have an image to convert that are color 32. So convert me that to byte the fastest you can. Now that we have byte, we need to store in the file. The stuff is that you need to keep the wide and the height because you need to add after. So you put it on the file system, and when you have time, you will reload it and then convert it to a PNG. And so you need to keep the height and the wide. Okay. A good information I want to keep is when the photo was taken. And here is the millisecond we will really need for the animation part, because that's how we can know that this image is associated to this part of the animation. And I store it in a format that I call color of 32 to say, yeah, it's just some color 32 of Unity. I go store them in the stuff, we store them, boom, boom, boom. Okay, we are happy. Then we wait 1 second to avoid that the loop is moving too fast. So 1 millisecond. And we check if the loop needs to die. Ta-da! So what we did here, and also what I do is every 5 seconds, I try to say to Unity, if you have something you want to flush it because you need a lot of memory, and the garbage collector of C#, can you remove the memory that is not used? Because you can say, okay, don't, it will automatically be done to collect it. But here, the stuff is that your memory is doing, so that the max memory is at the memory of your application, you're doing, and if you do that, you are dead. And so what I do is that I just ask the garbage collector to, yeah, could you please remove the memory? Because we are really in a risky situation. It's a really bad idea, because what I should do instead of doing that is do that, take that memory, make an array, and just store them in an array. And if the array is full, then I need to think about something, but try to have an array and not create and delete the memory, because I'm losing a lot of timing on create and delete. And also it's dangerous. So that is a bad idea, but for the moment I did that because it was a hackathon, I did not have the time. So yeah, so what we did here is just allow to say I want to store this image. He stored the image, and ta-da. And the part that is really cool is that by using the multi-thread system, at least on PC, because I did not try on other build, we really have the 250 megabyte per second of writing. So it really go right on the file, and so maybe be worried about your hard drive, because you can, so one recording can take 20 to 40 gigabytes of just 2 minutes. So it means that you write a lot of data. So if you do that all day long, maybe you will destroy your hard drive, because a hard drive can be read a certain amount of time. So yeah, just a warning. So yeah, that's how it works. You put your animator here, say that you want the animator time and not the game time, and then you say that you want to record here. So you can record with here. What I did is that you can just take some picture here or record the stuff. So if I press divide, it will record every frame. Minus will stop the recording of every frame, but at a high frame rate. And period here, it will just record at this period of time. So if you want 5 images per second here, for example, you just put 0.2, you press dot, and it will take image. So let me show you that. I press play. Here I press dot, and here you can see that we are recording some image. 32. So something fun to see when you want to see that is here. So you can see here that the disk is used a bit, not a lot, but used a bit. So it's storing stuff, but not a lot. And here I think it's stopped. Like this. Ah, shit. I know. Wait. I know what's happening. It's because I changed some setting, and so now run is not set on. So what's happening here is that as soon as I'm outside of Unity, stop recording because I forgot to, if I switch the run in backgrounds, and Unity, okay, running backgrounds. Where are you? Windows running background. Okay. Here. Yep. So for the moment, shit, I will try to do that. It will be easier. Okay. So for the moment, we have something that is taking a little bit of hard drive, like you see 6, 9, 10 megaoctet per second. So you can see that here the image thread is going up. So it's recording kind of a lot of image, but it's okay. But it's 1% of the writing. But if now I want to record a lot of FPS, like 60 FPS, I press play here. And I say, could you record everything? And as you can see here, 60, 80, 100. So here you can see that the weighting is still 0. So it's recording a lot of image over there. But at some point, when the garbage collector will try to flush it, it means that a lot of image will come back in the queue. And here you should see some image coming in the waiting queue. For the moment here we have 6 threads that everybody is taking some stuff to write. So you can see that here we are 160. So for the moment it's not going too far. Maybe if I put 2 threads it will be, oh yeah. Here we are at 25% of the stuff, of the animation. And if you want to see the memory stack, here, if we go in performance here, you can see that the memory is really almost every time at the end, and it's storing garbage, storing garbage, storing garbage. So it's really at the limit of breaking every time. And here you can see the hard drive working a lot. So here we are sometime at 100% capacity, sometime not, but we are doing a lot of writing. Yep. So I don't know what it will be on Android, but yeah, you see here, you can see that the curve over there, the curve here is when you have some, when the computer is like, oh, I cannot deal with it anymore, and he tried to queue them, and so as it queue, there is six thread that is taking all the file and doing, I need to write, and that's what's happening here. Do I have a better solution? I don't know. That's the best solution I found for now, but it's working well. So I will stop it here to show you what it gives. So up. So we have, for the moment here, we generated 5,000 image because we were at like 60, 10, 50, I don't know how many frames per second. We'll see that. And they did store that at the persistent path. So where is the persistent path, you will say? I need to see in the console, but the console is not there. So I can maybe press play and then do a screenshot and go over there. Yep. Up. Where is the persistent path? I don't remember that. I will check directly. Okay, bureau. Here. Is it the one of today? Yes, it's him. No, it's not. It's because now my game is called something else, I think. Build setting, player setting. Et ouais, écoute my music. Et là, écoute ma danse. So, hero experiments. My dance. And it did nothing. Okay. I don't know why. No, it's write something because we saw that it was writing something. So, where did he store that? And okay. I don't know where it was stored. I could check around, but the video will be long. So what I will do is just show you what it gives. So what it gives when you use that is that it generates those. So you see I did a 5 FPS, 10 FPS, 20 FPS, and it generates not this, but the color 32. Color 32, do I have color 32 to show you? Apparently not, so I will check around. So I asked them to write the persistent path. He gives that at the start, so technically the string should be there, but it was not because I don't know why. Up. Should be over there. Don't know why it's doing that, so I try to find the solution. What the actual fuck? Okay. I don't know. Oh, but if he did that, oh shit. Because if there is no pass, he will record near it. Okay, I have it here. So it should be at another place, but it's stored near the project here. So yeah, here is what it gives. So here you can see that you have here at 0 seconds of the animation, you have all that is stored. Yep. That's 0 is when it's not based on the timing. Here. So when I was recording at 1 second and 285 milliseconds, we have a screenshot, then another one, then another one, then another one. And you can see that here, that's all the screenshot I was generating. Okay. So you can see that between this one and this one, there is like 200 milliseconds. Between this one and this one, there is 20, 200. So all that, it's screenshots. But it's in color 32, meaning that you have always the same size because it's just Unity, you have a texture, and this texture is one color is 4 bytes. And so 4 bytes multiplied by wide multiplied by 8, and you have the size of what you are storing here. And if you look at it, you will understand that it's not compressed. So if you never check around what is an image, you can see that a lot of characters are the same because I'm using black texture here. So there is a lot of stuff that is useless here in the image, but that's why we use PNG and JPEG. Stuff that when you compress in PNG on JPEG, you lose a lot of time. And that's why when I want to convert it to a JPEG, I take this link over there. I go here in uncompress, I click here, I say the size because it was easier for me in the hackathon. It should be in the title of the image. Say the size of it, and I say, could you, I need to press play. Could you uncompress them in a PNG? And if you look at the code over there, what I do is I have a start routine, and what I do is that I create a texture, I read the file, I take the byte here, for all the file, I take the byte here, I convert that to color 32. When I have the color 32, I just create a new file that will be a PNG and a new file path. I set the pixel color of the texture. I say apply because I need to apply it before I can encode the PNG, I think, I'm not sure. Now I convert it to a PNG on the main thread of Unity, but I have time because we are not in the recording. I write all the byte and ta-da, I have a PNG. So if we go here, as you can see now, it's doing all the image here. So that is the image, and that is the color 32 we used to do it. You can see that here it's 4 megabytes, but at the end it's just those kilooctets that I used in the image when you compress it as a PNG. So we are winning a lot of size. So you really need a lot of space to store this image if you don't want to compress them with my technique. And here we go, you can see that it's starting to do that, and so you can take a coffee and it will do all the image one after another. So what happened is that now that you recorded the session of the user and that you recorded some pose of the user here, I will stop it. So we record some pose and some and all the image of the animator. What we'll receive is this. So I have the scenario, that is all what's happening in the dance here. This is on a GitHub online if you want, in the description. So and what I did is that I have the scenario in 5, 10 and 20 FPS in case the AI take too much time. I have the AI code that the guy in the hackathon did. It's a code that will try to compare the pose, and yeah, I don't know how it's working, but basically it's just a classic AI where you give some data set that say I want that, and you give all the image of the scenario. He will take all the image and just say I recognize it or I don't recognize it. What I had to give him was some pose. So all that are some pose that I want to track. A, B, C, D, E, F, G. So as you saw, when I press 0 and press 1, it generates those stuff. So it's plenty of image that are almost the same but not the same. So you can see that here it's I want this position here, and so I rotate everything and ta-da! So that's one position, and there is a ratio to give for the AI, but that I'm not the expert, and we did not do a lot of tests on it because it was at the end of the hackathon. But the idea is here. So you convert all those positions and the scenario, and then what happened is that we receive something like this. So I ask him to keep the title and use CSV as a format. So we have the size of the image, when it was taken, and the millisecond of the animation. And here, when you open it, we have the probability of being that. So here, for example, he is sure that it is the A position, and the other one is not. And there is a pose bad, and pose bad is I had to give him some position that is the one we don't try to track, and that pose bad, if I understood. So here what I do is that I have plenty of CSV here, and all this stuff is saying this frame I know he's in the position A, or I think it's position B, So it's just the AI trying to guess what position it is. So what I need to do now that we have all that is to import them. And so that's the use of that. So what you do, you go in the file over there, you go in the CSV to position probability here, and you say that you want to import. And what happened, he will read all the file, he will try to check the one that are over 70% of prediction, and he will store it in it. And so here you can see that he's saying that at almost 6 seconds, there is a lot of probability that is the I position. And here in 25 seconds, it's maybe the G position. So that the AI trying to guess the position, and that has 0.7% of probability on it. And in those files at least. The stuff here is that cool, now we have the timing, now we have probability. So if I go in the other scene that is not the capture scene, I will go here, ma danse, here you can see that I have something that is called import here. Okay, so as you can see, we have the CSV somewhere. Here we have the CSV post probability. So I say, okay, over there I have some stuff to load. When I'm in the editor, I import them. I have 63 event change. Okay, so that is the database of the event for this animation. Okay, so now that I have that, what I can say is that I want to run the animation, take the timing of the animation, and based on the timing of the animation, I want to check in the database if there is an event that needs to be triggered. And so that's what I do here. So you can see here, I say, okay, every update, take the animator, check the current state of the animator, convert that to the time in seconds, okay? You fetch in the source every event where the millisecond is over and under and equal this millisecond. So all these events, it means that there is something to do, and it is now. And so I say, could you invoke based on the position name, so A, B, C, D, E, F, G, stuff like that. And so here we trigger it and we push it. And so here I say, okay, if it's a A, it will be green. If it's a A, it will be, oh yeah, here there's a bug. I should not put A like this. But if it's A, it's like, B like blue, C it will blue, D it will be blue too, E it will be green. So that's how I change the color of the animation based on what the AI is giving me as a probability position. And the same here. So what happened is that after the game jams, I wanted to check if the AI was good or not, and unfortunately it's not good. And so what happened here is that I asked the AI to show me what position it was. So as now I know that he will predict A, B, C, D, I take an image of E, I take the image of A, of M, and here is what the AI is trying to predict. So you can see that M, and the stuff is that it's not M. That was not M. So here I can see that the position is not the good one. For example, here it's E, K. No, it was not a K. So that is the bad part of the project, is that I'm not an AI expert and we did not have a lot of time to train the AI correctly. So the project is here, but we need to train the AI correctly to understand that this is this, or yeah, to train it. So as you can see here, that is our start character, the one we talked about like 30 minutes ago. This is the camera position of this guy, and this guy is synchronized on this guy. You can see here. So what happened is that it's another trick to have. if you want to do this kind of project. So I have this guy, and this one I sync it on the other one. So here, over there, I have a code, and the code is saying, okay, do I have a source and do we have a target? If yes, I take the current normal time of the source and I apply it to the target, and like this I have the other guy who is running like this one, but who is with the good texture and the good background over there. That allow me to debug here, but that also mean that if you need to do an AI in real time, what you need to do is you take this rendering texture, you send it on the Wi-Fi somewhere else or on a script in Unity, and then you could technically guess position based on real time and not based on offline when how I did here. So instead of creating all those steps, you could maybe just say to the AI, is this image is the one I want? And the AI could answer yes or no and give you the position estimation. So yeah, long video, but it was a cool stuff I did this weekend. I was happy to do it. The code is online, so this project won't change. So the Git is called, I will check if internet allow me to show you, because internet is really bad today. GitHub, it's called Danse. Écoute ma danse. So if you go here at Écoute ma danse, you will have all the code source of this project on GitHub over there. You have the build for Oculus Quest that is over there if you want to try it on the Oculus Quest. I tried to put it on the links, but I had some problem with the texture, so you have the game, but you don't have the view of the camera and that side. So if I succeed to do it, I will put it here, but for the moment you only have the Quest 3 version over there. But all the code are over there, so if you want to check how I did it, copy my code and stuff, cool. But that's some shit code. I mean, it's hackathon code, it's quick, it's dirty, it's bad. So I try to take the time to use this code that I just show you, not the project, but the code I show you here, to try to use it on the links to be able to record the camera. And that's why I do this post-mortem video, because if I don't do it this week, I will need to do it in 1 month, and in 1 month I won't remember everything. So that's why I did this video. And if you watch it until now, I really thank you. I hope it was useful to you. Feel free to really go in the code and copy the stuff, and if it's 1 or 2 years after this video, maybe you should check in my toolbox if I don't have done a plugin that do it better, because here is my first version of writing, but maybe I will try to find a way. I did a Kinect version where it was using shader and job system to be able to improve the speed, so I will see if I need to use computer or job system to make it quicker or make it work on Android. I don't know. I suppose I will have to do it for the computer. Why I think that is because I need to check, but I think that copy the byte is very slow. So convert capture here when I record. Why you recorder frame thread here, here, here. I have several places where I can make it better, and in this place there is that. So this one is very slow, so basically it takes the color of the rendering texture, it takes it with the CPU one by one, or with the buffer memory, I don't know which one. It takes it and it try to read it, and that takes a lot of time. And I don't know if I can improve it. I need to check the timing of that compared to compute shader. But what I could do instead is take a compute shader, give the rendering texture, and use the compute shader to convert every data in the texture in something closer to a byte, or cut it in small pieces to be able to flush it on the Wi-Fi, or to don't have a big piece. I don't know. There is plenty of way to copy the memory in another part of the memory with compute shader. So that's what I need to try, and to see if the compute shader is faster or not to do that, because if it's not faster, it's useless. So maybe there is something I can improve here, but I'm not sure. But here is the bottleneck of my project for the moment: the read of the memory of the render texture. And so yeah, hope this video was useful. May the code be with you. Sorry it was a bit technical, but it was just a post-mortem for me to remind me how to do it, and I hope that it was useful to you. Have a great day. See you in the next video. Bye.